Alrighty then. Section 1.3, surface area composite shapes. We have a shape here, a cube, with a triangular hole drilled all the way through. And the question is calculate the surface area of this. So if you did this properly, if you assumed that there was no hole, you would know that the surface area of a cube would be 6 side squared. Side squared because one square face is side squared, and there are 6 faces, therefore 6 side squared. But this triangle, and I'll highlight it in yellow, or purple, I guess, and the other side of it, which would be on the other side, would also be purple. Those 2 purple triangles were lost in the surface area, so I would have to say subtract 2 triangles, which is base times height divided by 2. Now, a smart person might say, if I multiply base times height divided by 2, and I think about 2 as being 2 over 1 multiplied by that, by cross reduction, what would I really have? Base times height. And that's actually because if I drew that triangle here and cloned it, just to show you why, and reversed it and butted it, what shape did I create? That's called a parallelogram. A parallelogram's area formula is always base times height. Now, if that had been a right triangle, and I cloned it, and turned it, if it was a right triangle and I cloned it, what shape would that have made? It would have made a rectangle. Base times height is the formula for a parallelogram. Length times width is the formula for a rectangle. And that's why when you divide it by 2, you're either actually getting half of a parallelogram or half of a rectangle. So the formula 2 multiplied by base times height divided by 2 would allocate the missing triangles at both ends. But the hardest part is realizing that we're adding 3 rectangles. And I suppose the easiest way to think about that is if you were standing right here, and I asked you to look through that hole, the floor that you would be standing on in that particular cube would actually be a rectangle, wouldn't it? And the dimensions of that rectangle would be 3 meters wide by how many meters long? 5, correct? That not only would be the floor, but it would also be the ceiling to your right and the ceiling to your left. So we'd actually have 3 rectangles that are all the same measure. Because that's an equilateral triangle, all 3 of those rectangles will be the same. When I substitute my information, that would be 6 multiplied by 5 squared. Take away 2. Now the base, I'll use my highlighter here. The base is that. The height is that. So we'd have 2, 3 multiplied by 2 divided by 2's. Plus we'd have 3 rectangles. The length of that rectangle is 5. So we have 3, 5, and the width of that rectangle, as we said before, would be 3. So by substituting all our information, we get that. Now we just have to use BEDMAS to solve it. Exponents first, so we get 6 times 25, which is 150. Take away 6 divided by 2 is 3, so 2 times 3 is 6, plus 3 times 5 times 3 is 45. Once we do that, we're going to solve that. 195 take away 6 means my final surface area of that particular composite shape is 189 centimeters squared.